to discuss Zooniverse. This is a citizen science project. Originally called Galaxy Zoo because the first task people were asked to do with it was classifying galaxies. Since people who wanted human help for this project were not expecting to get much. They thought maybe a few people would come and help. They crashed their servers that first weekend. Because people actually wanted to help astronomers conduct research. Why did they want help? Because there are some tasks that are excellent for computer scripts. There are some tasks that are still generally better done by people. Those tasks that are best done by computer scripts? Any modern astronomer is a capable computer programmer. But the tasks best done by people, well, we need people to do them, so. Okay, so Zooniverse comes in. Anymore, you don't have to be an astronomer. It's not all projects on are even astronomy anymore. They want people to collaborate. Large numbers of participants need to find projects that interest them, learn how to classify, and submit their classification, and that helps with real research. Okay, then in turn, the researchers build the project with the Zooniverse. They'll submit it for approval and launch the projects and download that and get to publish the results. Now, from time to time, yes, you can watch this video if you like, but I'm recording my own video. I don't need to try to put video in video and see what happens. Right, so notice, alright, so in the upper right corner, well, I've had an account on this site for years, ever since I was a grad student hearing about this for the first time. And then as a faculty member at a few institutions, I said, okay, I need to make you do something besides prove that you've read the book. So, or at least absorb its contents. Alright, so, yeah, just so you know my level of credentials. What? Oh, that's why it doesn't show any classifications. It says last 7 days. It's true that I haven't logged on in a week. Now, okay, so you can see what happened. Well, my own personal involvement to now. It's okay. So I found out about this in 2011 when I made 22 classifications. Then I made 4 more in 2019 as I was teaching a class where I thought I should make a few demonstrations for the students. Well, I made 62 classifications in 2020, 41 21, and 13 22, and 7 and 23. Alright, so submitting a copy of this, or perhaps, let's see, and just so you have an idea of how much time I spent. Well, let me know that you've done your share. I'm not going to ask you to do 100 classification. I've touched 22 projects, made 149 classifications, and spent a little under 4 hours on it over the course of my life. Okay, now, so, all right. So what do you? Well, but what about? That's what I've done with it. And just so you know, okay. So yes, Project Hunt. I've previously worked on a Planet Hunters project for the math likers. I looked at old planetarium maps and had to tell what constellation was getting mapped. Looked at close-up maps of Mars. Looked for asteroids. Waiting for Mars' South Pole. Dark energy. Well, but I mean, now not all those projects are even still active. After all, it's been a while since I set up my account. Now, there are currently 86 active projects as of this recording. Okay, now, what is this? Alright. Not all these current projects are things I want you to do. Okay. I would allow you to do any of them, but for purpose of class credits, we must choose things that are relevant to astronomy. Okay, so let's, yeah, okay, so let's, right, yes, I'm a physics guy, I'll just take a quick look, but, yeah, most of these physics projects are space related, but I'll go ahead and go for space science. So we have up here 28 projects in the space science category. If you want to, you can do you can do projects from any of them. What I want you to do is actually contribute to research. And note that giving them fake data is not really contributing much. Now, they don't naively believe you, but they'll compare it to what others said. If you are consistently wrong, they can use that information. If you're consistently right, they can use that. What they can't use is random guessing. Alright, so let's try. So this is the newest project available, cloud spotting on Mars. Oops. You're allowed to use it. Okay, now 382 volunteers have made 5,498 classifications on it. Alright, so what do we do? Well, we can press learn more. Okay, clouds on Mars. Alright. I know we haven't even studied Mars in this class yet. That's okay. Because even if you don't know anything about clouds on Mars, if you've lived on this planet for long, you at least know what clouds on Earth are. And clouds on Mars, I mean, aren't necessarily the same, but should be similar enough to not require special knowledge to do this. They can warm and cool the atmosphere. Okay. All Mars is dry, but it has a tiny... If there is some water vapor in Mars' atmosphere, they can form water ice clouds. Now, nowhere near what you need to get, say, the recent flooding on Earth, but... Yeah, so... You also can get carbon dioxide clouds. Try. Oh, why would I have you do this? The people in charge of this project want to know about the daily, seasonal, or annual patterns of Martian cloud shapes and distributions. How will cloud and what will the cloud forms relate like prevailing wind patterns? The structural similarities between Earth and Mars cloud types point to streamer formation mechanisms. Okay, so that's their broad question. Hey. Alright, so they then sent out the imaging ultraviolet spectrograph. That takes a UV picture of the entire disk of Mars. Measure water, ice, and dust content in its atmosphere. Most images have dust or haze, but large clouds are observed regularly. These notes can tell us water, ice present, might tell us something about atmospheric conditions. So, say we are on Earth and we have prevailing winds behind a mountain, and a series of waves could come behind them. So you can see this wave right here. Okay, that's a picture on Earth. As wind pushes moist air back up the mountain, it can rapidly cool and condense, and you get some kind of cap cloud on top. And it can help us know about how steady wind is, or what the availability of water vapor. So, try to do the same thing for pictures on Mars. Okay. So they're trying to find 6 major cloud types. And they want to know how they appear, different seasons. Alright, more background information, you can click these links. No need for me to. If you're in an online class and you can't click a link, we have issues. Okay, let's see about classify. Okay, so what they're asking you here is, are there clouds in this image? First off, okay, so we'll go on tagging them if they exist, but first let's find out whether they're unique cloud shapes. Okay. Well, I see this pink, and alright, let's see this green bubble. I see this white one. I think that's cloudy. Alright, these are okay. And of course, and they'll even give you an option to say this image is too broken up to see anything, man. Why would they give you this option? They're feeding images off directly to you that you haven't even looked at. There's too many for the main research team process them all and get rid of them immediately. Yes, they're generally cloudy regions, but okay. All right. Alright, now let's just so let's take a look at the tutorial. Yeah, so the UV images, we shift them into red, blue. Okay, cloud watching. You don't know whether they're distinct clouds. Okay. Bottom image, 2 dots represent 2 different versions. First view maps down the globe. Second view shows the surface view. Alright, so find something whether it's bright as a cloud or a crater. Okay. Curved lines indicate where the. Alright, so they've identified 6 cloud types. Okay. Disk clouds, so these things is vortex clouds, Surface. Dotted clouds. Gravity wave clouds. Twilight clouds. Streak clouds. Okay, so that's a streak cloud. Okay. And then, yes, data like this. Okay. Alright, so that's the streak cloud. Okay. So they're just in cloud shapes. Okay. There we go. Is that a disc? Oh, a disc. Disc clouds. Okay, there's a disc cloud. Oops, I drew one that I shouldn't have. I don't think I see another streak cloud. Okay. 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 What do we see in this image? Do I see a few distinct clouds? Okay. Alright, I think that's a vortex cloud right over here. Looks like it's spinning around something, so that's... Oh, right here, some kind of streak. That's... Alright, if you look... Twilight cloud. Yeah, it's right over here. Okay. And that's what I could see. Now, all right. So that's one of the projects. I'll now try another one. Just give you a chance to choose the one that fits you most. All right, Science Center. Plus Brazilian project. Okay, learn more. This is the robotic telescope in LA to finding filter system. As so different wavelengths can be photographed. Okay, so we're trying to find asteroids, galaxies. It's an exotic object. So asteroids, just rocky galaxies, large number attracted by gravity. Those appears disk. Green objects might have some H alpha emission that's often associated with stellar formation. Exotic objects, well, anything. Asteroids will appear as stripes in different colors because they're moving across the sky. Galaxies, okay. Green objects, okay. Exotics, okay. They look weird, okay. Okay, so, okay. Green dots, no. Alright, so green dots, galaxies, asteroids, or exotic objects. Well, I don't see anything green. So okay, these are right here just bright stars. Oh, this right here is a little dragged line. That must make it an asteroid. Okay. 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 There's one up at the top. Looks like an asteroid. Amongst these other stars. Well, that looks like an asteroid right here. I don't see anything else besides a bunch of stars, so I'm going to click done. I'll take a look at this image, see what I can do. It's the last example of this. Alright. Stars. Alright. Oh, that's a green object right here. Okay. Right, okay. Okay, so that's what okay, so that's another project you can do. X asteroids? What? Okay, let's exoasteroid. It's just an asteroid that orbits another star. Okay. They're looking for what asteroid? Around white dwarfs? What do you care? So just okay. Okay, so they were making sure the white door was placed in the center. Is the white door changing brightness? Okay, so what? Yeah, so you can use the education FAQ section. Or so let's. Okay, so looking through a flip book. Left channel's regular, black points dimming, and white means it's getting brighter. Okay. This is the object near the center of the image. This is nothing. Okay. I'm not seeing any changes, so I'll just mark no. Nothing's changing here, so I'm just going to mark no. Okay, so oh, but this is changing, so yes. Okay. That one is changing. Alright, now so you can that's 3 projects you could choose from. I will allow you to do any of the other space projects if you like. I don't claim to be an immediate expert on all of them. Oh. Oh, well, okay. Catalina Sky Survey. Well, okay, that's slightly different because I actually have done astronomy research that concerns the Catalina Sky Survey, so alright, alright, okay, Val. Alright, so Catalina Sky Survey was measuring all variability of the whole sky. Now, I'm a published scientist regarding my work finding stars that change their brightness. I am not a published scientist regarding asteroid detection through the Sky Survey. Okay. Alright, so these are regular asteroids. Okay, not exoasteroids like the other project. Alright, so use the apparent movement to recognize that. Okay, when you find the green circle, there's one object that moves from brain to terrain. Some of these are just stars. Okay, it's not getting bright. Okay. 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 It's not getting brighter frame to it's changing its brightness too much frame to frame, so it must not be a real object. I see this as a little more than background noise. Okay. You know, that does appear to be real, so. Alright, now. Alright, there. Alright, so. I've set several examples, so you can